Welcome back to the Deep Dive. Today, we're getting into something that sounds like a pretty major shift in software engineering tools. OpenAI's GPT-5-Codex. The sources we've looked at are painting a picture of something.
Yeah.
Well, beyond just code completion, we're talking genuine autonomous work.
Oh, absolutely. It feels like a big deal for developer tools, doesn't it? Our mission today, really, is to figure out what's technically different here, what makes Codex, Codex.
Right.
We're moving past the idea of AI just finishing your lines of code. This is supposed to be an agent. True autonomy.
So we need to look at its training, right?
Yeah.
The performance metrics.
Yeah, how it actually performs on specialized tasks, and crucially, how it operates differently day to day compared to, say, older models or competitors like Claude Code.
Okay, and that big claim, the one everyone's talking about, coding for 7 hours straight, that's
Yeah.
quite a hook. So for you listening, the core question we're tackling is, what actually enables that? What's the tech that allows for that kind of persistence and depth? Let's unpack it.
Right. So the fundamental shift the term OpenAI uses is true agentic autonomy. Think about older models. They were reactive, right? You give a prompt, you get a response.
Yeah, command and response.
Codex is meant to be proactive. You
Yeah.
give it a high-level goal, something like refactor this entire service to use this new dependency, and then it basically takes ownership of the whole process.
Okay, so when you say agentic autonomy, what does that actually look like in practice? What steps is it taking by itself? Is it just writing code or more?
It's the whole sequence. It plans, first breaks the big task down.
Okay.
Then it does the coding, runs the tests, unit tests, integration tests, whatever's there. It finds the bugs, debugs them, and then importantly, it puts together the pull request review package.
All with minimal human handholding.
That's the idea. Minimal guidance needed during that cycle. It's like the difference between asking an intern to write one function versus telling a senior engineer, here's the project, deliver the tested result. That's the agentic part.
Got it. That's a huge difference. And the key to making it stick to these long tasks seems to be this variable grit concept. What exactly is grit in this context? Is it just throwing more compute at it or something algorithmic?
It seems to be a bit of both, actually. Variable grit means the model can adjust how much reasoning time and, compute effort it uses depending on how complex the job is.
So simple bug fix, quick response.
Exactly. That's low grit, almost instant.
But for the really hairy stuff,
Yeah.
like refactoring a huge, messy old code base.
That's where the persistence, the high grit comes in. The sources say it will keep working, iterating through different approaches, running tests, trying again.
For 7 hours or potentially even more.
Yeah, continuously if needed, until those tests pass. It's allocating serious resources compute, internal reasoning cycles to problems that would just make a standard LLM give up or, hallucinate something useless after a few minutes.
And the quality of the code it produces.
Mm-hmm.
I thought it was interesting that the training wasn't just about volume, but about actual engineering workflows. It sounds like they wanted it to feel less like an alien dropping code in and more like a teammate.
Exactly. And two things seem key there. First, the training apparently included a lot of real-world messiness, commit histories, bugs, CI/CD logs, the works.
Right.
Second, it's designed to respect project conventions. It reads existing standards docs, like agents.md files.
Okay, hang on. Agents.md, for listeners who might not have seen that, what is it?
Think of it as like the team's specific rule book for the AI. It codifies things like coding style, security practices, maybe libraries you should or shouldn't use in this project.
Like use camel case here, or never import this old library.
Precisely. And because Codex reads and follows that file first, without you needing to spell it all out in the prompt every time,
Okay.
the code it generates just fits in better. It feels more like code from someone who already knows your team's way of doing things. Clean, maintainable.
That definitely sounds like a step towards production-ready AI code.
Yeah.
Okay, so how does it manage that 7-hour loop? It needs an environment to actually run things, right? What's in that sandbox?
Yeah, tool integration is absolutely critical here. It operates in a secure sandbox, which lets it treat the code as a live system, not just text.
Meaning it can.
It can actually run the code, debug it in real time. It can access debuggers, profilers, figure out performance bottlenecks.
Wow.
It can also actively search documentation, look things up on the web if needed.
And what about front-end stuff? The sources mentioned GUI testing.
Yeah, apparently it uses screenshot analysis to do GUI testing, which is pretty interesting.
And crucially, for the human overseeing this, there's transparency.
Absolutely vital. Everything the agent does is logged. You get diffs showing the changes, full execution logs, even citations if it pulled info from the web. Accountability is built in.
That real-time execution, the tooling.
Yeah.
That sounds like the core utility leap. But Running in a sandbox is one thing. How do we know the code isn't just fast, but actually good? How do they benchmark this?
Good question. So you look at the standard benchmarks first. On SW Bench, which covers a wide range of tasks, GPT-5-Codex scores about 74.5%.
Okay, which is pretty solid. Roughly matches the general GPT-5 model, right?
Exactly. That's your baseline competence.
But here's where it gets really interesting, right? Where the specialization shows up, the refactoring tasks.
This is the payoff. When you test it specifically on those complex multi-step refactoring jobs, think Python, Go, tricky stuff across multiple
The
files.
kind of thing that needs that variable grit.
Precisely. On those tasks, its accuracy jumps way up. It hits 51.3% compared to the base GPT-5, which only gets 33.9%.
Whoa, hang on. A nearly 20-point jump. That's almost 50% relatively better. What does that actually mean in practice?
It means it succeeds much more reliably on the kind of big, messy engineering challenges that would just stump a general LLM. It shows the persistence and the methodical approach actually work for things like large migrations or paying down technical debt. It moves it from being just a helper to potentially a reliable partner for those big jobs.
And then there's code review. Huge buzz around that. OpenAI apparently called it a safety net internally.
Yeah, and engineers seem to agree. There were reports that when the system went down briefly, people felt kind of exposed, which tells you something about reliance.
Wow.
And we have concrete examples, Duolingo using it for back-end checks, catching compatibility issues humans and static analysis missed.
Okay.
RAMP apparently credited it with catching a serious bug right before deployment.
That's significant. And there was mention of a 90% drop in cloud task completion times. That sounds almost too good to be true. Where's that speed coming from?
That seems to be partly infrastructure optimization, things like better container caching in the execution environment.
Yeah.
But a big part of the perceived improvement, especially for review, comes from how it explains things. It prioritizes diff-first explanations.
Meaning?
Instead of a wall of text saying why it did something, it shows you the code changes first the diff, and then gives targeted explanations just for those changes. Makes human review much faster, less cognitive load.
That makes a lot of sense. Okay, we know how it works. We know it performs well in its specialties. Let's talk choices. Why pick Codex over, say, Anthropic's Claude Code? What are the trade-offs?
It really seems to boil down to the task. Codex clearly wins on tool integration and that sheer persistence for hard, long-running problems. It just has more grit.
Okay.
Claude Code, though, users often describe as feeling, well, snappier, faster for the quick, simple coding questions or completions, the kind of thing you might have used older assistants for.
But that speed comes with a potential downside. The sources mention something about how rigorously they check things.
Yeah, that seems to be a key difference. There are reports that Claude, maybe to be faster, sometimes guesses. It might assume a database credential exists or a certain column is there without actually checking the config or schema.
Ooh, risky.
Right. Codex, because of its methodical approach and the tools it has in the sandbox, is apparently designed to check those things first. So it might take a bit longer for some tasks, but the resulting code is likely cleaner, more maintainable, and probably safer for production systems, especially complex ones. More type safe, too.
So Claude might be faster for a quick fix, but for deep surgery on a production system, Codex seems like the more reliable choice.
That seems to be the consensus, yeah.
Yeah.
Safer for structural changes.
What about comparing it to the top-tier general model, GPT-5 Pro? Does the specialized Codex beat the general powerhouse?
Not across the board, actually. GPT-5 Pro scores a tiny bit higher on the general SW bench, verified 74.9% versus Codex's 74.5%.
Interesting.
And for tasks like high-level architectural planning, brainstorming solutions to really tricky problems, that initial design phase, people often prefer GPT-5 Pro. It's seen as the better high-level thinker.
But there's a catch for the actual implementation.
Exactly. GPT-5 Pro typically has a smaller context window. It just can easily handle reading and manipulating, hundreds of files for a massive refactor.
Huh.
That's where Codex shines. Its whole agentic setup, the tools, the persistence, it's built for that kind of heavy lifting. So maybe you use Pro to sketch out the plan, but you hand it over to Codex to actually execute the migration across the whole code base.
Pro's the architect, Codex is the very capable construction crew.
Kind of, yeah.
Yeah.
The high-performance worker bee, specifically designed for those big, long-running jobs.
Okay, but even the best tools have quirks. The sources mentioned rough edges and gotchas. What are the real-world frustrations people are running into?
Well, someone on Reddit put it perfectly. The model can be brilliant one moment, mind-bogglingly stupid the next.
Okay.
It sometimes gets stuck on minor edge cases or goes off on unnecessary tangents, adding complexity where none was needed. Users call it churning. If the initial plan hits a snag, it can sometimes lose the plot a bit.
Sounds familiar. Almost human. Any examples of spectacular fails? Helps contextualize that 7 hour straight thing.
The failures are mostly about wasted effort, losing coherence. Like you ask it to refactor one function and it spends 2 hours trying to pull in some totally unrelated library.
Right, not crashing, but spinning its wheels.
Exactly. Which just reinforces that the human needs to be the manager, the one providing oversight and quality control.
So what are the tricks? How are experienced users managing these quirks to actually get work done?
They're basically learning how to manage a very powerful but sometimes erratic junior dev. Tactics include just resetting the session if it starts going off the rails, giving it smaller, more focused tasks instead of one giant instruction, and actively telling it not to pursue certain complex paths.
Okay.
Which brings us back to that core trade-off. Need quick prototypes. Maybe Claude is faster. Need thorough, reliable work on a complex, high-stakes problem. Codex is probably better if you're prepared to guide it past those potential tangents.
That clarity is really helpful. Okay, finally, let's touch on access. How do people actually use this? It seems like there are a few options.
Yeah, they've tailored the access. For developers who want maximum control, there's the Codex CLI, command line interface. It gives you things like auto-generated to-do lists for the task, different approval modes like read-only suggestions or full auto-run with constraints, or just let it rip.
And you can tweak the grid.
Yep, adjustable reasoning effort settings to control that persistence.
What about integrating it into existing workflows?
That's where the IDE extensions come in. VS Code, Cursor, other editors, brings Codex right into your project. Apparently, these have seen huge uptake already, like 800K installs quickly.
Wow.
And then there's Codex Cloud, a web-based option. Persistent workspaces, handle setting up temporary environments. You can even check on it from your phone via an iOS app, good for remote work or monitoring long tasks.
And getting access is through the standard OpenAI tiers. Plus, Pro, Enterprise. API access is coming later, it seems.
That's right. And the consistent feedback is, if you're tackling something really hard, make sure you select the high reasoning mode. That's what unlocks the full depth, the 7-hour capability.
Okay, so summing up the technical implications. GPT-5-Codex really does seem like a breakthrough in autonomous software work, especially for those complex, long-haul tasks like major refactoring or deep code review.
Yeah, the kind of stuff previous LLMs just couldn't reliably handle because they lacked the persistence and the tool integration.
But the golden rule from all the sources is keep the human in the loop.
Absolutely.
Right.
It's an amplifier, a powerful one, but it doesn't replace judgment. The question isn't, can AI do this anymore? It's shifted to, okay, how do I help the AI do this effectively?
Right. The people getting the most out of it seem to have made that mental shift. They're not just using a tool, they're coaching an AI teammate.
Which leads nicely into a final thought, maybe something provocative for you to consider. If these agentic models are the future, then maximizing their value might depend almost entirely on architecture.
How so?
While the companies that will likely see the biggest gains are probably the ones who start optimizing their code bases now, breaking things down into clean, self-contained, well-tested modules, designing their system specifically so that these incredibly capable, but still occasionally quirky, autonomous agents can easily understand, manipulate, and iterate on them safely. The future gains might be all about designing for the AI agent.